Hello everyone and welcome back to another YouTube video. In this video, I'm going to be showing you something pretty cool that I've created. It's actually a very simple project, but it is something that I think is a very good kind of a beginner project. So for people who are just starting with like artificial intelligence and neural networks, and I just felt like this project was something that was looking pretty cool, and I just thought that I'd make a video on it. It's not the most complicated project, it's a very simple project, but it is something that you can, uh, use as a starting point to do more complicated projects. In fact, I am going to be uploading a few videos where I'll be using like not exactly this project as a base, but we are going to be using some skills that we learned in this project in those other projects. So basically, what is this that I've created? This is actually a financial sentiment analysis tool. uh, Basically, if you don't know what it means, um, you got all of these things. Like, basically, if I say that a company is doing really good, their share price is going to go up, that's a positive sentiment, because I'm predicting a growth in the company. Whereas if I predict that a company is going to go out of business, then that is like a negative sentiment. Or maybe if I just say the company is doing normal average, that's like a neutral sentiment, nothing too crazy. So the thing is that if you are doing anything like trading and stuff, you will see that every single one of those trading apps have that little, like, they have this little thing like the market sentiment, which you can kind of assume is basically all of these financial sentiments, and they probably just average it out and get a perfect sentiment. So that's kind of what's happening in the real market. So I thought that we could create a tool that could allow us to do this. So the data set that I'm using, I actually downloaded it off of Gaggle. You can just search for like Gaggle financial sentiment analysis. So this is the data set that I'm using. As you can see, there we go. So you can just download the data set over here. If you go ahead and look at it, it's a pretty simple little data set. It's just two columns. So yeah, it's like this, and then they actually have the sentiment. And yeah, so there are basically three sentiments. It's neutral, positive, and negative. So as you can see, it's neutral, positive, and then they have negative. So that's basically the three sentiments that we have. And right, so now let's just go ahead, and I'm gonna walk you through the process of actually creating this neural network. So actually, I've already, as you can see, coded this out. I'm kind of gonna walk you through the process, and I will have all of this code on GitHub. So what you can do is you can just clone this repository in like any directory, and then you can kind of just walk through the process. Because for me, I've been doing like neural nets for a long time, and it took me so long. Like, this is like, it took me so long to actually code this neural network out from scratch. Do all of this data processing by hand and all of that. And in the end, even I actually had to and do this stuff by by copy pasting it. So yeah, so let's just get started. So first, I've imported all of the libraries that we're going to be using. They're all like pretty standard libraries. Now, since we are going to be using TensorFlow, I've imported TensorFlow and Keras from TensorFlow. I've imported NumPy, Matplotlib. Then we have obviously imported pandas, because that's what we're going to be using for the data loading, all of that stuff. So that's why we have imported pandas over here. Next, we have two things. It's tokenizer and pad sequences. Both of these are, as you can see, pre-processing libraries. You can perform tokenization of your data. Convert the data into like those number representations. That's why we have the tokenizer. And there's also another way to do this. I actually forgot the name. It was something like text to vector or something. I know, I'm pretty sure I'm not saying it right. but there is another way to do something like this. So yeah, um, all right. So these are basically all of the libraries that we are gonna need. Next, I've just read in the data, just a simple little statement, pd.readcsp, and here I'm just getting the head of the data, so you can kind of get an idea of what the data looks like. Because never really opened up the data, I never really looked at it over here. I know it's not a very good thing to do. You probably want to look at the data first, like in something like Excel or something, just so you can get a bit of a idea of exactly what the data is, because you can't do a whole lot of stuff in pandas, like the things that you can do with Excel. The next thing that I'm doing is I'm just getting the fields that I require. Now in this case we have like these two columns and we need both of them. So I'm just loading it as sentences and sentiment. So I just do this and I just convert it to a list. The next thing that we do is we just convert everything into a numpy array. So we can just say converting the sentences and sentiments into a numpy array. So that's basically all we are doing. Now over here I'm just creating the training and the testing data, because we did not have any um, we just had the sentence and the sentiment, and like in just one file, which was like this data CSV file. We did not have two files, like a train CSV and a test CSV. And since I wasn't gonna open up Excel and pick up n number of columns, put it in the training, create a new file, put it in the testing, I wasn't gonna do that. So all we are doing is, after we load in the data and convert it into the desired format, I just specify a train size, which is just going to be the length of the sentences minus 100. So that's just going to be the train size. And once I get the train size, I'm just taking the train sentences, which is going to be the sentences numpy array, and we can just grab from 0 to the train size length all of the sentences you have between these two kind of boundaries, you can say. And then the test sentences is going to be from the train size length to everything, so the last 100 sentences. The same thing we just do with the train sentiment. But currently we are still running into a bit of an issue, because if you look at the sentiment, it is positive, negative and neutral. Now that is actually a bit of a problem, because it is positive, negative and neutral and not a digit. And we all know that neural networks are pretty good at classifying digits rather than text. So what I'm doing over here is I'm just replacing positive with 0, negative with 1 and neutral with 2. Pretty simple stuff. It's actually very simple code, as you can see. Yeah. Now I'm pretty sure there's a method in pandas that allows you to do this a lot more easier, but I kind of did not remember that, or I wasn't really bothered to do that. So I just kind of did it with a simple for loop and added a couple of if statements in there. So it wasn't really a problem. The next thing is we use a label encoder to basically take the train sentiments and fit transform on the train sentiments. So basically you can get that as like this encoded. I really I kind of don't know what the label encoder does. This code I basically copied off of Stack Overflow. Basically the reason why you do this is because initially you are using a string, then you typecast it into a float, and when you do something like this and you feed it into a neural network, for some reason the neural network was going a little crazy, so that's why you basically do this. So you basically just want to add these 3 lines of code. It's not a whole lot. So once you do that, you actually gonna have to perform, I would say, one of the most important steps for the sentences. So it's basically you gotta tokenize the training text. This is gonna be the only piece of processing that we're gonna do on our training text. So so basically what we are specifying over here is a vocab size. So these things, these are all like pretty basic hyperparameters. I would say the main things that you kind of need to care about is just the vocab size and the max length. the trunk type, padding type, and the OOV token. Those are the three things that I basically had to copy paste because I don't know what these things stand for, and I don't actually think that they make a huge effect on the model. So you kind of don't need to have them, so don't worry. So here I just have the vocab size. I set it to 10,000 and the max length to 100. I think they are pretty good. So next we just define the tokenizer with the number of words and the OOV token, and then we just spread it on the training sentences and we get the word index. Next we basically just pad it and do the same thing with the test sequences. Now finally we are done with all of that. So now what we can do is we can basically create the model. So this is, as you can see, a pretty simple model. We are using an embedding, then we are passing it through a couple of dense layers, and yeah, it's a pretty simple model. What can I say? So I just have this embedding layer. If you don't know what an embedding layer does, it basically will take the data, kind of basically like, so if we have good and bad, then it's going to be opposites from each other. So basically it will represent the data as a, I'm sorry, as a vector, and it's gonna have like a, so basically a good vector, let's say, is pointing in the left direction, then the bad vector will be pointing towards the right direction. So basically it does something like that. So we basically create a model compiled with a sparse categorical cross entropy loss. Again, the reason is we are having 3 nodes in the output layer, so we obviously are gonna need to have a sparse categorical cross entropy instead of a binary cross entropy. The next thing we do is we just fit the model. As you can see over here, we start with a pretty big loss and a 48% accuracy, but we do go down to a 15% loss and a 90.8% accuracy. I would say one thing that you could do is you could just evaluate the model, which is something that we can do now. I don't think we can't do that. And then over here I'm just getting the model summary and I am saving the model. So as you can see over here, this is the model summary and we have also saved the model. The next thing, this stuff, I think it basically reverses the word index. Basically I think it converts like the word index that we had, that little big chunk of tokenized words, we convert them back to the original thing. I think that's what we are doing, pretty sure, because I copy pasted this piece of code. I wanted to do that, so I copy pasted it. Here we are basically dealing with predictions, nothing too crazy. I have just defined the class names over here. We get the prediction and the probabilities. I also got it, the probabilities over here, so you can kind of get an idea of what the prediction is. So over here I actually know what the test sentence was and I know that it was positive. So we can also get like, so that's basically what we want in the end. So now let's actually go ahead and run this. Actually we don't even need to run it. So yeah, so that's basically the entire model. As you can see, a pretty neat little model. And yeah, it does work nicely. If you go ahead and look at these graphs, you can kind of get an idea why it's a pretty good little model. Like, it started off with a low accuracy. As you can see, it slowly increased. You can like, it wasn't exactly very slow actually, it's a pretty steep increase, and in the end it kind of stabilized out at a 90. You obviously want to peak it out at like 9900, but like, to be honest, the model that we are going with is a pretty simple little model. So a 90% accuracy on a model like this is, it's pretty neat. So then if you look at the loss, it's what you want. It starts at a pretty high value, 100% loss, and then we obviously go down. We went down to like 15% loss, still a little high. You don't want that much of loss, but I do feel like this is a pretty neat little neural network. So I think you can also, like, if you want, you can just save this stuff I'm sorry, just you could just kind of save this, figures just as a bit of a thing to upload on GitHub. So I think we could do that, but yeah. Now the thing is, this model is pretty simple, so it's gonna be pretty good for you. So, cause even if I don't actually end up uploading the actual model, like the model files, cause if you go ahead and look at it, as you can see, I have this entire model file. If even if I don't upload that, you guys can basically just run all of this and get it. The main reason being, this is a very simple model, because if you look at the data size, it's actually just this much. It's not a big data set. So yeah, it's like a really basic data set, so you can basically work with it a lot easier, and you kind of don't need to have like a 2 to 3 hour training time. This literally took me like a couple of seconds to train, not even a minute, I'm pretty sure. So yeah, so that is it for this video. I hope you enjoyed it. It was pretty fun to make. So comment down below what videos you want next. Text classification, image generation, detection, um, you know so yeah, you comment down below. Give me a couple ideas, and I will try my best to implement them. And until the next time I meet you,